We classify matter. Scientists classify stuff. You get all this information and you have to make some sense out of it. And so we classify things. One way we classify matter is by its physical state. Is it a solid, a liquid, or a gas? So these are the three states of matter. And here we have an illustration showing us a familiar compound, water, in all three states. When water's in the solid state, we call it ice. In the liquid state, we call it water. And when it's in the gas state, we usually call it steam. But we experience water in all three states in our everyday lives, and so that makes it a good thing to talk about. Here we have an illustration of the particles in water, and these three states differ in how the particles are relating to each other. In the solid state, we have the particles being close to each other and being fixed relative to each other. If you look carefully, you can see that there's some order here, that these molecules are lined up. In the liquid state, the molecules are still close together, but they're not lined up, and they're moving about relative to each other, but they're still close. In the gas state, you've got the molecules being much further apart, and they're just moving all over the place. There are also three physical states of students. Right now, you guys are in the solid state. You're sitting in chairs in rows, and you're not moving relative to each other. Are you being absolutely still? I hope not. You should at least be breathing, right? Breathe. That's a good thing. And, you're scratching your nose, maybe you're taking notes, you're shifting around because you're bored out of your mind. But, you're moving a little bit, but you're not moving relative to the students next to you. That's what solids do. In this table, the molecules in the table are moving. They're just wiggling around, but they're not moving relative to each other. When something melts and goes into the liquid state, then the particles can move around. So in lab, you guys are in the liquid state. You're still in a close, confined area. We're still very close to each other, but now you're moving around. The gas state of students, we don't have a bell that rings, wouldn't that be nice? But when class is over, the door opens and people just go off in different directions. And then you're far away from each other and moving completely independently of each other. And that's what a gas does. The gas particles just go off wherever they want, and there's lots and lots of space between the particles. So these slides just kind of summarize what I just said. So solid matter, the particles are close to each other, and they are in fixed locations. They do move, but not relative to each other. And we should also note that solids have fixed volume and rigid shape. So think of an ice cube. You take an ice cube out of the tray and you put it in a bowl. Does its shape change? No, it stays what shape it was frozen in, right? Does its volume change? No, it doesn't. Solids retain their shape and they retain their volume. There are two broad categories of solids based on how the particles are arranged. So in a crystalline solid, there's an order to the particles. There are different ways of ordering the particles, just like we could order this room differently. This one has things are in a line this way, and then they're in a line diagonally that way. And going up and down, it looks more like a zigzag. But there's a pattern. There's a long-range repeating order. So that's crystalline. We can also have amorphous. Amorphous means without shape. A is a prefix meaning without, and morph has to do with shape. Cartoon superhero morphs into something else. He changes his shape. Amorphous, without shape. So in an amorphous solid, oh, I didn't mean to do that. All the particles are just kind of jumbled together. In a solid, though, they're not mixing, but it's like you brought in a bunch of people and you said, sit down on the floor. Are people going to sit in rows? Probably not. It's just going to be a big jumble. That would be amorphous. But you guys are crystalline because you're sitting in rows. In the liquids, atoms are still close to each other, but they're free to move around. liquids have a fixed volume because the particles are still close together, but they assume the shape of their container. So you take a cup of water, maybe in a tall, skinny cup, and you pour it into a shallow baking dish. Does the shape of the water change? Yeah. Ice doesn't do that, it's solid. Liquid water changes shape when you put it in a different container. It takes on the shape of the container. Does the volume change? No. It may look like it changes, but it's the same volume. So liquids have fixed volume, but their shape can vary. And then gases. Gases have a lot of space in between the particles, and so they are compressible. Gases are compressible, liquids and solids not so much. Let's look at this illustration. Here we have a solid, and we've got this in a container with a piston. And if we push down on this piston, can we squeeze those atoms any closer together? No, because they're already touching each other. They're already as close as they can get. You can't compress them further. But with the gas, there's a lot of empty space. And so you can push down on this and push the particles closer together. You can compress a gas. Gases always assume the shape of their container and the volume. So they're a little bit like liquids in that they take on the shape, but they also take on the volume of the container. So this table just kind of summarizes that information in terms of the motion of the particles, how they're spaced, the shape, the volume, and the compressibility. And so you should be familiar with those ideas.